same medium at the same time in the same place. When they do, they interact with each other to form a different disturbance at that point. The resulting pulse is obtained by using the principle of superposition. State the principle of superposition pulse. So the principle states that when when two disturbance when two disturbance occupy the same place at the same time at the same time, and the resulting disturbance the resulting disturbance is the sum of two disturbance. Okay, so that is how we define, or that is how we state the principle of superposition of powers. It says when two disturbances occupy the same place at the same time, the resulting disturbance is the sum of the two disturbances. Okay, so let's move to 6.2. Disruptive interference takes place when two pulses meet and result in small amplitude disturbance. The amplitude of the resulting pulse is the sum of the amplitude of two initial pulses, but the one amplitude will be negative number. Okay? Use theory of destructive interference to draw pulses of different amplitudes emitting from different directions to demonstrate this theory. Okay? So what we have here is that this is what we have. Destructive is destructive. Okay, listen, we have constructive. Yeah? Constructive is when we have something like this. This one will be like this, going this way, and another one will be like this, going this way. This is constructive. They are going to construct. Okay, they will result in bigger things, like in bigger house, like this. They can result in something like something big. You see, something big. So, but now we are asked to do what? Destructive. So, destructive. So, destructive. So, it means we will draw something like this. Okay. One will be coming this way, going to the right, and other one will coming this way, going to the left. You see? So, this is the first thing to draw. Okay. And then now we want to draw the result. So, the result will be something like this. It won't be that big. This is our result. So you were supposed to draw something like this. So this one is on down, moving to the left, this one is on top, moving to the right. So this one is going to reduce this one. So that's why we have something like this at the end. I hope you get it. Okay. So this is how you draw, or you draw to demonstrate this theory. Okay. So let's continue. Please guys like and subscribe and share this video to your friends so they can also pass. So let's move to 6.3. It says a pulse covers 3,37,5 centimeter in 1,25 seconds. On a heavy rope, calculate the pulse speed in meter per second. So guys, we know that speed is given by distance over Okay, so what is our distance? My distance is 37,5. Do we deal with centimeters or meters? We deal with meters, so let's convert it. It means 37,5 we're going to divide by what? By 100. So we get 0,375. So meters. So we deal with meters, we're supposed to start by converting. So it will be like 0,375 divided by time, you are given 1,25. Okay, we press our calculator, we're going to get 0,3 meter per second. 3, 0,3 meter per second. That's how we calculate our speed in this case. I hope you understand it. Okay, thank you so much. Let's move to the next question. Okay, yes, the next question that we have. So it's question 7. They say trans transverse wave is traveling along a string. A point on a medium carrying the wave is observed. A graph of displacement versus time of the point is shown below. The vertical distance between a quest and a trough is 3,2. So you know this is crest, right? This is what this point trough. Okay, so they're telling the distance from here to here is what is 3,2. That's what they're telling you, 3,2 centimeters. Again, they gave us in centimeter. We must convert to meter. We deal it with in meters. Okay, so we are also given time. So another thing that you must do, we must count waves. So from here to here, that's one wave. And then from here to here, another wave. From here to here, another wave. It means we have three waves here. Three waves. You must know how to calculate waves, okay? So from here, going down, up until here. It's one wave. Starting from here again, this is another wave. From here until here, it's another wave. So we have three waves, okay? So here's the thing that they say define a transverse wave. So 7.1. A transverse wave is a wave where the movement is a wave where the movement of particles of the medium is what is perpendicular to the direction of what? Of propagation of wave. Okay, we see it's a wave where the movement of particles of the medium is perpendicular to the direction of propagation of wave. Simple as like that. So what are we meaning? So 7.2, it says how many full waves are there between 0 and 21? And we could just counted it. Okay, remember, I'll just use different color. From this point to this point, that is one wave. A wave must have crest and a trough. So it means again from this point to this point, another wave. Why? We have crest, we have trough. And then again from this point to this point, it's another wave. Why? We have crest and trough. So how many waves do we have? So the answer is 7.2 is three waves. Okay, so let's see have another question here. Here they are. Okay, let me clean. So they say from the information given, write down the amplitude of the wave. Okay, so remember there's this information here. The distance between the crest and the trough is 3,2. So it means from here to here. That is what? 3,2. So what is crest? From 0 to here, it will be what? So we see 3,2 divided by 2. We're going to get 1,6 centimeters. Okay? Or you can start by converting what? 3,2 divide by 100. So it can be what? 0, 0.032, right? Okay, I think so if I'm not mistaken. And then meter. And then what is half of this? You say therefore 0,032 divided by what? 2. You will get 0,016 meter. So this one is either you wrote this as your answer or you write this as your answer. Okay? So thank you. Let's move. Okay? Calculate the period of the wave. Okay? So period is the same as time. Do you know the formula that says T is equals to 1 over time? It's 1 over frequency. Okay? So what are we going to do here? So they want the period, they want the time. Okay? So um okay. So what are we going to substitute here? Yes, 0, 1, 0,21. How many waves do we have? We have 3. So divide by 3. And then we press our calculator. We're going to get 0, 0, 0, 0, what? 0.07 seconds. That's how it takes to complete one wave. Okay? It takes 0.07 to complete one wave. Okay? So let's continue. And then next question says, or the last one, if wave length of the wave is 4 means 0.4 meter, calculate the speed of the wave. So it's simple. Do you know the formula that says speed is equals to lambda divided by what? Divide by time. Okay? Time. Then you see the wavelength is what? Is 0.4. Remember, we calculated time that takes to complete one wave is 0.07. So we divide by that time with 0.07. And then we press the calculator 5,71 meter per second. Some can use another formula, it's fine. Okay, but you will end up in this answer. So let's continue, guys. Question 8. It says, grade 10 learners studied the relationship between frequency and wavelength of different types of EM radiation. Okay, so define the term electromagnetic radiation. So 8.1.1, electromagnetic radiation is a self-propagating is a self-propagating wave in a space with electricity actually with electric and magnetic component. Okay, so that is the definition. And then they say arrange the following type of EM radiation in order, increasing wavelength. Okay, so it's simple. I will write them down once. Okay, so it's increasing. You know the spectrum, right? You follow it. So it's 8.1.2. What is the number one? Gamma rays, it has a low wavelength. Gamma rays, because why? It has a high frequency. Okay, and then secondly, here we have what? Well, X-rays second. X-rays, remember, X-ray, gamma rays has a high frequency, and then it follows by X-ray. And then what? I think ultraviolet, né? Yeah, ultraviolet, ultraviolet light, and then followed by visible light, and then lastly is what is infrared, infrared light. Okay, that's all we're supposed to do. And then 8.1.3, ultraviolet radiation is dangerous and can cause skin cancer. Explain how this radiation causes cancer when your skin is overexposed. So they want to know how ultraviolet radiation is dangerous to your skin. Okay, when your skin is overexposed. So guys, these rays, number one, you're gonna say 8.1.3. So these rays has to have a higher frequency does, and then does they have higher degree of penetration. That is the reason. Degree of penetration. That is the reason why it can cause skin cancer. Okay, so and then give one use of each of the following types of uh, electromagnetic radiation. So 8.2.1, you know what X-ray use? They use me. So they use X-ray. They use to produce what? To produce photographs of internal organs, such as bones. You know, in your organ, they take it to X-ray so they can be able to see what happens to bones. Okay, that's it. And then microwave. Uh, this one, we always, everyone has microwave in his house, right? We use microwave to do what? To heat food or cook up food. That is the use of microwave. They mean the same microwave that you have in your house. So 8.2.2, we use microwave. They can be used to heat or cook up food. That's it. Okay. Last question 8.3. Calculate the wavelength of radio wave with a frequency of 2.1 multiplied by 10 to the power of 8 Hz. So it's simple. You say C is equals to 2.3 is equals to frequency multiplied by wavelength. Use this formula. We know C is always what? 3 multiplied by 10 to the power of 8. We are given a frequency of 2.1 multiplied by 10 to the power of 8. We are looking for wavelength. So wavelength is gonna be 1,43 watt meter. That's it. Okay, so let's continue to last question. Please like and subscribe and share this video to your friends. They say the particles nature of light can be demonstrated by the interaction of photons with matter. One way in which the light interacts with the matter is via the photoelectric effect. Define photon. Guys, I'll write it here 9.1. Photon is a quantum, okay? It's a quantum of light. Some can say it's the energy packet of light or energy packet of light. Energy packet of light. Okay, so that is the definition. And then 9.2, the infrared beam emitted on a projector removes a wavelength of 1,3 micrometer. Calculate the energy of a photon of this infrared radiation. So it's simple. You know this formula E is equals to Planck's constant multiplied by C divided by wavelength. So that's what I calculated. H is there in your information sheet. That is 6,63 multiplied by 10 to the power of minus 34. What about C? Also there it's constant 3 multiplied by 10 to the power of 8 divided by. We are given wavelength 1,3 micro. Micro, okay? So it's what? 1, micro means you multiply by 10 to the power of minus 6. And means multiply by 10 to the power of minus 9. That is the difference. So here we're going to say 1,3 multiplied by 10 to the power of minus 6. You just press your calculator guys, and then you will get 1,53. 1,53 multiplied by 10 to the power of minus 90 watt joules. That's it. So thank you so much guys. Until we meet on the next video. Good luck on your exam.